This video is going to cover section 2.6 on the skewness and the mean, median, and mode. And this is a really short section that just talks about the shape of our data and how it relates to the mean, median, and mode, the center of our data. So we've seen these all three of the things that we're about to see and talk about, we've seen before. So a symmetrical distribution, we have here a symmetrical distribution and the histogram that represents that data set. So if you look at the data 4, 5, 6, 6, 6, etc., you can see it's perfectly symmetric. The mean, if a vertical line can be drawn at some point and the left and right sides are mirror images of each other, then you know your data is symmetrical. In this case, because of this, this is a perfectly symmetrical distribution, the mean and the median are going to be exactly the same. This is a unimodal distribution, so the mode is also the same as the mean and the median. If you had a bimodal symmetric distribution, the mean and the median would be the same in the middle, and then you'd have those two modes on either side of that. So in a symmetric bimodal distribution, the two modes would be different from the mean and the median. But you can see that this is perfectly symmetrical with one mode. So here's a new data set, 4, 5, 6, 6, 6, 7, 7, 7, 7, 8, and its histogram. So in this case, the mean is 6.3, the median is 6.5, and the mode is 7. So this data, the distribution is skewed to the left. So if the tail seems pulled to the left, I realize that as I'm doing it in the video, it looks like the other side, pulled to the left, then it's skinnier in the skew. The skew means something has taken the bulk of our data and pulled it in that direction. And what it is are these bigger numbers. A few big numbers can change the shape, the distribution of our data and the way it looks, and then that will change the mean more so than anything else, but the median and the mode. So the mean in this situation is less than the median, and both are less than the mode. The mean and the median both reflect the skewing, but again, the mean is more affected by it than the median is. So flipping it over, we have this new data set where we have more data at the lower end of the graph, but we have a couple of high numbers and they have skewed our data out to the right. So in this case, the mean of this data is 7.7, the median is 7.5, and the mode is just 7. So if you have that little skinny part being pulled out to the right, then it is skewed right. So it's a little bit opposite of what we think. So as I said, and in this case, the mean is greater than the median and both are greater than the mode because it is skewed to the right. Mean and median both reflect the skewing, but the mean more so. And then things to note about the mean, median, and distributions in general. The mean is affected by outliers that don't affect the median. We saw that in the last section. Since the median splits it right down the middle, the outliers don't really affect that. But when the distribution is skewed to the left, the mean is often less than the median. When the distribution is skewed to the right, the mean is often greater than the median. And in symmetric distributions, we expect the mean and the median to be approximately equal in value. Now, these are just general rules of thumb. They are not always the case, or they could be close, like the mean and the median are approximately equal, so they may be off by a little bit, because that first one we saw that was perfectly symmetrical, most real data doesn't fall that way. You've got, pretty symmetrical, but not perfectly symmetrical data or skew data. And we get exceptions, especially in sets of discrete data to these rules of thumb. So that's it on the skew and the mean, median, and mode, and that is the end of the video for section 2.6.